Hi, I'm Andrew.
My name is Alejandro Bautista.
I'm Richard Liu.
My name is Benjamin Lehman.
I'm Lupe McIntosh. I'm a senior physics major here at Harvey Med, and I'm part of the Sandia National Labs clinic team.
One of the really important sort of limitations right now with technology is that energy storage is very limited.
We're trying to measure the dielectric constant of barium titanate nanoparticles as a function of particle size.
Barium titanate is used in pretty much any capacitor. They're the part of the circuit that can store energy and then discharge it.
When we're looking at really high dielectric materials, they're useful in making ultracapacitors that can be used for all kinds of energy storage, power leveling, regenerative braking in electric vehicles. They're really pretty much in any technology.
It's said to have a very high size dependence on its electric properties, and if we can extract those properties well, then we can make much better capacitors at storing energy.
Our project has two phases. One of them is manufacturing the samples and actually putting the nanoparticles into some epoxy plastic so we can make samples and measure them. And then my part of the project is making computer simulations of those samples so we understand the theory of what's happening behind them, and then we can put them together and understand some material properties of barium titanate itself.
So along with Ben and Ale, I make up the manufacturing team. So we create the samples from scratch. We receive a powder from a company in Japan, and we create our thin disc samples from scratch by breaking up any agglomerates that we see and then suspending them in an epoxy matrix.
The reason we're making them is so that if we can make these things uniformly and well and everything, we can determine the dielectric permittivity of this entire composite by measuring them as if it were a capacitor. And that's exactly what Andrew does after we're done with it.
So I've been focusing on characterizing our samples and our nanoparticles. So that means I'm measuring the final composites using electrochemical impedance spectroscopy. I've been looking at the particles using our scanning electron microscope at Pomona. Pretty much anything we're measuring something, that's been my job.
We've just been working hard on making consistent and reliable samples for testing so that we can really definitively say, this is what we understand and this is the observation that we're making. And so it's been an important part of the job, just trying to get that consistency.
If barium titanate nanoparticles can get to these very high levels of dielectric constants, we can get really powerful capacitors.
They're helping me do part of my research. So I basically allocate part of what I'm responsible for at where I work, Sandia National Labs, to the Harvey Med Clinic team, and they're helping me deliver on what I have to deliver. So that's been very helpful.